How I learned Haskell in 15 years. At least it's like slightly better than how long it takes to learn C++. All right. Haskell is a programming language invented sometime in the 20th century by Scottish logicians as a prank. 15 years or so ago, for reasons I can no longer remotely recall, I started learning Haskell. Now, I have finally written a useful program in Haskell, and I'm pretty sure I can do it again if I ever need another computer program. Sounds about right. This sounds approximately correct. Oh, I do have one worry though. Evan, if word gets out you've successfully written a program in Haskell, I mean, there might be white papers calling for your, for your resignation. I just want you to know that. No action's going to happen because it's going to be white papers. But I'd be very, very worried if I were you. Many white papers just might be put out into the ether. I don't know how I learned functional programming in general, or Haskell in particular. I was following Why the Lucky Stiffs projects by 2006 and reading Leigh Nikirichin's pioneering tumble log, Erich Chaya. Oh man, I can't even read those words. And either of these sources may have exposed me to the world beyond OOP. Leia posted a link to Pandoc on my Anarchaea in December 2006, which could have been when I first learned about my favorite piece of software and language it was written in. By my first year of college, 2007, 2008, I had certainly, by the way, by this point, I've already failed out of college twice and became reformed. Come on. What are you doing 2007, okay? Please, that was my third year of college, which was also my first year of college. You know what I mean? Easy. I had certainly heard of both functional programming and Haskell because I decided I should learn how to use them. I contrived to do an independent study in functional programming with the help of my next door dorm neighbor, who was a Common Lisp fan and Emacs user with 4 LCD monitors. Damn it, 4 LCD monitors in 2007? Shee! That's expensive at that point. That is expensive. My textbooks was Programming in Haskell by Graham Hutton, which I assumed was the recommended somewhere else on the Haskell webpage. I don't recall if I got any credit for the independent study, but I probably installed GHC successfully. God knows how I managed that. I could have been using Fink or Mac ports. I bet I learned about map and folder and probably heard of the M word. I didn't really learn any Haskell. I mean, the first step to learning Haskell is to not learn Haskell for a good straight year. That's step one, is you got to prepare your body and soul by going on a 7-day meditation journey with Jonathan Blow. Later, that same year, Real World Haskell by Brian O'Sullivan, Don Stewart, and John Gerausen. By the way, 3 authors just to propose the idea that Haskell can be used in the real world. It's just too good. It's like life is art, but unknown to thee. It had real world in the name. I got a copy of it at some point and even read some of it. I would have been using the same computer. So if I was in fact to write any code, I probably didn't have to install GHC again. I was not and am not all that good about sitting down with any kind of technical tutorial and following along doing the exercises from beginning to end. And it turns out that flipping through a book without doing anything with it isn't too useful. This is a fact of life. And thus, I didn't really learn Haskell. By the way, this is such a fun observation he's making. I also really generally struggle just following along a very simple technical tutorial doing step-by-step building something. I need something that I mean, for me, when I was young, I was much better at it because I didn't know anything. So I follow through how to make a first-person shooter video game in C++, or I'd follow along something else. But then once I get past a certain point, it's like I can't follow a tutorial because I'm like, give me that shit, I'll just do it myself. You know what I mean? I don't know what it is, but it's just it's impossible now for me. In 2009, I got a notebook. Remember notebooks? Literally says notebook right there on the front cover. Also my favorite movie. I got a notebook. Remember notebooks? Some of you weren't even born. I got an Asus E of some model number and other, and put Arch Linux on it. Probably because my helpless fascination with Haskell, I chose Xmonad as my tiling window manager. Your Xmonad configuration is just a Haskell program, and you effectively recompile Xmonad with it to reconfigure your window manager. Isn't that neat? Dude, I still remember, I want to say his name was Connor. Why can't I remember the kid's name at Netflix? He always wore a suit and tie to work, and he always just talked about Haskell nonstop. It was so good. It was so good. I got a netbook. Okay, so netbooks. Okay, everyone's telling me that I had a dyslexic moment. Perhaps This is not what he meant by a netbook. But look, this is how I plan my shorts. See? It's exciting, huh? Anyways, well, read that one wrong. Netbook. That's that classic. What is that, a Sony? Is it Sony netbook? Is that what it is? Is this old the thing old people call paper? Yes, paper in this economy, absolutely. So I finally had an environment to write some Haskell where I had a goal in mind. I don't think I learned much about programming in Haskell from customizing Xmonad. The example config was extensive, and I believe I customized more by subtraction than addition, cutting my config down to one full screen and one split layout. Set up some keybinds, put something in the status bar, that kind of thing. At some point, I stopped fiddling with it and kept using the laptop. Success. Great success. For some time after college, outside perhaps a couple of casual stabs at that didn't go anywhere, I attempted to make use of Haskell. I did, however, frequently use software written in Haskell, possibly just because it was written in Haskell even. I can't say I've intentionally ever used any program written in Haskell. I'm not even convinced that it actually exists. Let's see, certainly that was the reason I tried out HLedger instead of Ledger when I tried out plain text accounting for the first time in 2011, 2012. It turned out to be too depressing to track personal finances while I was unemployed. I get that. I feel that. I may have been a contributing factor to my decision to try Darks as my first distributed version control system during college instead of the still emergent Git. By the way, I never once was told a single version control software in my college years. And I kid you not, when I went to my job and they said, we use Git, you know what I did? I read like the 5 commands I needed Git for. I'm not going to lie to you. I am going to say something that I think is really important for a lot of people to hear. If you think learning Git or not learning Git is going to make a difference in you getting a job, you're just dumb, okay? I hate to tell you this. It doesn't matter. Nobody cares. You can learn it in 13 seconds. It's not a big deal. Git, push, pull, commit, add, clone. There's like 5 commands you need to know to get started. You don't even need rebase. Rebase is just a flag to pull. You can do that later, okay? You can do that tomorrow. Merge or rebase. I am always a rebase guy because I properly know how to use Git. Thank you. Merge is for people that don't know how to use Git. Rebase is for people who know how to use Git. Sorry. Rebase, not worth the headache. Again, it just simply means you don't actually know how to use Git. I mean, I hate to tell you this. That's just how it works. Rebase is actually trash. You don't know how it works then. It's just that easy. Yeah, but this is crazy. I would never do -I in there. Why would you -I? Why not? Dude, just git pull rebase. Crazy. You know, you guys aren't reading the docs and it's showing, okay? You guys aren't reading the docs and it's showing right now, okay? I is interactive, yeah, okay. Y'all have never worked in a large project that has releases, have you? It's showing, okay? You know why? Because sometimes you need the revert. And if you use merge, good luck with your revert, buddy, okay? Good luck. Good luck. What do you mean? I just have 17 commits and 14 merge commits. What do you mean? This will be easy to This will be easy. We only roll forward. Rolling forward is such an internet point of view. You know what I mean? Rolling forward that only exists if you work on simple web apps. There's like times where that just doesn't exist. And like, that's that. Have you ever worked in a large team where you actually make an error and stuff has to get out for a project and they're like, you need it fixed or you need to get it out now because we must get this thing out. The end. Like, this idea that you can just always fix forward is a dumb notion. It's just a dumb notion. Do you squash? Yeah, I squash too. Yeah, no. Then asking your DevOps team, oh yeah, you know what you should do? You should just cherry pick all the commits that we want onto this one branch. Get the fuck out of here. Get the fuck out of here. My goodness. We had like 100 people committing to the television UI code base at Netflix. You can't just assume you can roll forward. That's like not a thing. Folke did nothing wrong. Folke did nothing wrong. Finally, I made a significant progress towards learning Haskell by learning Elm. Elm, I do like the Elm style of architecture for doing some UIs. I think it's very, very interesting. I like it. You can definitely see early React definitely had a strong Elm influence. You know what I mean? You can really see that, and I think there's something very interesting about it. Elm bears a deliberate resemblance to Haskell, and its compiler is built in Haskell. But where Haskell materials can overwhelm the casual reader, the generalized abstract nonsense, Elm's embrace of constraint helped it present a friendlier face. In 2016, Elm 017 came out and consolidated its focus on the Elm architecture and the interactive browser application. This was a big moment for Elm's mindshare, and it filtered into my conscious at the right time. At work, at the time, our newest and freshest JavaScript stuff was built with AngularJS. Speaking of AngularJS, do you think they have responded yet to my my tweet? Hold on, sometimes you got to refresh things. Do you think they have responded yet to my tweet? No, they haven't. Dude, you know for a fact they're going to get pissed. I bet you there's a meeting right now where they're just like, guys, everybody sit down. We're having a little impromptu stand up. Okay, everybody, what's the situation? Is we got somebody posting some material online that we're not sure if we support. What do we do here? All right, first person. But mistakes make the world. People are mad on Twitter and you're laughing? Yeah, I am that guy. I enjoy the chaos. All right, anyways, at work, let's see. Okay, I could barely understand how it was meant to be used, and I couldn't evade feeling like we were using it wrong. It seemed like an unprincipled mishmash of states and templates and mutations. Two-way data binding confounded me, and any separation of logic from presentation could easily be escaped, making it even harder. I selected Elm for a standalone dashboard page providing a friendly, filterable view of some data pre-aggregated from various sources. Building an Elm app following the Elm architecture hooked directly into my tiny brain was capable of. You have a state. The web page is rendered as a pure function of the state. When you interact with it, it sends a message back to your app, and you process that message and produce a new state. This is a very simple way to look at websites. Honestly, this is a very, very simple way to do things on websites. And I bet you that in today's day and age, you could probably drop the entire virtual diffing. You could probably drop everything and make an exceptionally simple website and just apply the changes, and things would probably work out fairly well, right? I think at this point, the amount of complication coming from making things fast, like there's this thing that happens that we all do, okay? It's a very interesting thing. I'll tell you an interesting story about Netflix with this as well, and I see it all the time. So one of the biggest kind of like learnings I've ever had at Netflix was the following, is we had this idea of destiny, which if you're in the application, there's several videos that are within your viewport. So what we do is we fetch the video data for the ones we think you will be most likely to watch. Fetch like the first 2 seconds so we can have really fast startup time. The problem is we tested this in 2014 and it worked incredible. In 2022, we were having memory problems. And when I looked at where the memory was going, it was going here. So I had a bold and innovative idea. Turn off prefetch. Because at one point, this was an optimization. But guess what? Optimizations that worked at one point don't always keep working. And what did we find? We had less errors, we had more free memory, and people generally used Netflix more and had better experiences by making things not as fast. Sometimes simpler is better, because often people don't care about 50 milliseconds saved. They care about something working well. How did I convince my boss? It took a year of convincing people and going to meetings. This was an extremely hard test, and there are emails that are literally called Fate, the Destiny test, because this was originally called Destiny, or as I like to call it, the Fate of Destiny. And eventually they kept saying no. One of my biggest risks I actually did take at Netflix was called the Fate of Destiny. And that is because when I did it, everybody said no. I turned off, I can't spell Destiny. You got the idea. I'll just take that out. Destiny. There we go. I got it. And here's the thing. Every last boss at my job said no. Absolutely not. Tested. It's perfect. So after about 1 year of meetings, you know what I did? I did it anyways. I allocated 50,000 people to a test and see if I could see any signs of something being better. And when things looked much better, we then put 10 million people in the test to prove, am I right or am I wrong? And this literally resulted in millions of more dollars of revenue by simply reducing errors due to memory usage, thus causing less application crashes. The fate of Destiny. Destiny being prefetching of video. Sometimes you gotta ask for forgiveness, not permission. Why'd they say no? Simple. Who would say, hey, let's have worse play delay as a test? Who would ever suggest such an outrageous idea? Anyways, how many Marco Polos would this be? It was about 1/8 of a Marco Polo. Yeah. By the way, I saw a raid in there. Hey, I would like to say thank you, Christoph, for that raid. Can we get a shout out for Christoph? Local maximum problem. Anyways, I say all those things so that you know about a very important kind of concept, which is that when React was created, DOM was slow. So this idea of being able to do really, really fine grain updating, but doing the processing in JavaScript and having this really complicated state machine, should component update, all that stuff, it made a lot of sense. I know DOM is very slow, but slow is much more relative than it was. Okay, updating 100 elements was like a full second back then. Updating 1,000 elements is like 1/10 of a second today. Different. And should component update is the reason why we now have React server components when you really think about it. Thanks, we have better hardware. No, we not only just better hardware, we actually have a huge improvement in a lot of the algorithms, right? Yeah, wait, DOM is faster because of implementation of hardware. Way better implementations and better hardware in general, right? Like, we got to remember 2013 versus today, your phone has vastly changed, right? We can all minimally agree on that one. Isn't it largely because CPUs got fast? No, we have much better ways to control repaints. There's a ton of things that have gotten a lot better. Your 5-year-old phone is still much, much, much better. Basically like how cars work in a dark forest, effectively. Goalie Squad, thank you. JT Larmy, let's go. I'll say thank you in a moment. The old days of jQuery when it was slow as molasses. Yeah, it's changed a lot. By the way, the Elm architecture, I think, is actually extremely nice. And if you've never understood the Elm architecture, it is what originally inspired React. Effing kids. They're always just yelling. Summertime with kids just yelling. What's our Elm architecture? It's really, really simple. Elm architecture just can be summed like this. You have effectively a update and a render that happen. And so in comes data. You update, you produce a state. The state gets rendered. This should look really similar to React. And then when a new event comes in, you re-update the state, you re-render. Speaking of rendering, did you finish the tower defense game? We're just starting it. We're building the actual game now. Isn't that every application ever? Yeah, but Elm architecture really like solidified this. Like in Charm, it goes init, update, view, right? It's a very nice kind of thing. And then update can return more commands, which will thus cause more updates. It's very, very nice. It's very, very nice. I don't know, but that shirt is sick. That's right, Chuck Carpenter. I wonder, Chuck, who designed such a sweet shirt? A nice little circle of arrows going one direction. I built a whole interactive client-side browser thingy, albeit a read-only by myself, something I hadn't done before, and it was really pleasant. Someone saying this is called MVC. It's not quite the same because it's all one direction. It's different. It's one direction. It is MVC. It's a variant of MVC, but it is one direction. You know what I mean? It is also suggesting data flow. So does that make sense? Hopefully that makes sense. Elm constrains the programmer to building one kind of application with restricted set of abstractions on a single platform. Operating within those constraints with the real project to work on was a great way to learn not just a language, but also the more general language-independent principles that the language and platform are built on. An illustrative example is the matter of encoding and decoding a JSON data to the domain types. In the mainstream dynamic languages, Perl, Python, Ruby, and JavaScript, I love that Perl is thrown in on the mainstream dynamic languages. Let's go. Nothing makes me feel better. Let's see. Dictly typed. Dictly? Bro, what's a dictly typed programming? Is that supposed to be like dictionary typed language? Is that Dictly? Dictionary based programming? Dude, Dictly typed is so cursed. That might be the most cursed thing I've heard in a long time. Let's see. Programming is common to begin with. It's quick and uncomplicated to build business logic around dictionaries with implicit expected sets of keys. Once you're calling an external API and decoding it as JSON, it's quite natural to just take the dictionary you get from that and pass it around without inspecting it at the point of decoding. That's what Zod and all these things people are trying to do is actually you do decode it. When your app crashes because a key is missing from that dictionary, it in certain situations or constrains an unexpected null, contains an unexpected null, you probably add a null guard at the point of use and move on with your life. Elm's JSON support, by comparison, nudges you explicitly to decode JSON responses into a domain model algebraic data types used elsewhere in your application. There's no support for just decoding your request into a heterogeneous dictionary with arbitrary depth. You must map your response to something, and you must handle the cases where your decoding fails when your data does not conform. By the way, this is awesome. And null guard is like the null coalescing operator. Well, I mean, that is a type of null guard, but no, it's not. It's not. So Rust or Go or any language like that, this is a very good thing to do. Effectively, what he's trying to say here is that, let's say you decode something and you expect X and Y as properties inside your object. If you don't get both X and Y in the way in which you defined it, then you get an error instead, right? Just because only X showed up, well, guess what? I'm sorry. That's not what I expected. I expected X, Y, right? And it's actual type safety, because what happens here is that with actual type safety, it converts it into a real type, not a fake type, right? Because in TypeScript, a lot of people just get by with as user, right? That's not real. You know what I mean? I know now we use Zod and other things. I get it. But generally, people don't use Zod, right? Options are just fancy tuples. That's a little bold of a statement. By the way, I love this band. I've just discovered them just a couple days ago, but the Cannons, man, they're good. They're really good. Yeah, Zod is good for this. Exactly. Zod is really good. Zod is good for this. Zod is not the best. Zod is also extremely slow, right? Like, you just got to understand that if you Zodded really hard, you've just pegged your RPS of your server to like no more than 19 just by using Zod. So, is it perfect? Anyways, since I had a blast with Elm and I knew that I was learning stuff that I should map to Haskell reasonably well, I started sniffing around once again for a way in. What I found was Shake, a Haskell library for building systems. During a talk session at a conference I had to attend, but barely any reason to pay attention to, I started hacking together a static site builder for the directory of markdown documents my colleagues and I started accumulating as internal documentation. As my Xmonad config years later, I didn't have to get incredibly familiar with Haskell to follow Shake's breadcrumbs to a functioning solution. This was good for my ability to produce a satisfactory documentation site, but it also meant that even with my comprehension boosted by Elm, I still doubted that I really understood Haskell. It's so funny. Dude, this is so good. Even though I built a bunch of stuff with it, I still am not sure if I actually get Haskell yet. Okay. Somewhere during this whole period of my life, I watched Gary Barnard's seminal talk with Boundaries, which makes a case for employing immutable data and pure functions in the context of object-oriented dynamic languages. Obviously, I cottoned on to that idea. I don't get the phrase I cottoned on to the idea. My next job's main language was Python, which had recently grown data classes, and I structured a few different chunks of code around them, even inside legacy code bases, which mostly factored quite differently. I started saying that I liked to write Python as if it were Haskell, despite still not having super meaningful experience writing in Haskell. My favorite instance of this approach was in the context. By the way, I do want to rewind here for one quick second. This is really good, by the way. Yeah, it's a React shirt pick. You like it? It's absolutely beautiful. I will say this is something that's really amazing about programming in general. Even basically a basic understanding of another language and how it approaches a problem fundamentally different can change how you write in a different language. This is why I so often tell you, learn other things. Don't just do JavaScript. Try Go out, because even how Go is used will meaningfully change how you write JavaScript. So always take a moment to just explore. My favorite instance of this approach was in the context of an application managing the repayment schedules for an internal loan portfolio. An earlier departed developer had implemented this schedule generation process in a dictly typed style, distributing the business logic of the loan schedules across various functions. In a bit of a mismatch, the web application request handlers and database update queries. When the customer brought up inconsistencies or errors in how the schedules would get updated in response to payments or other changes, it was a subtle process figuring out where the logic error even was and how to durably correct it. When I finally had enough of this, by the way, this is like every legacy project I have ever been a part of. Could you update it? Not meaningfully. When I had to finally get enough of this, I sat down and rewrote the repayment schedule generation from scratch. The basic, the classic right there. The basic task was given a sequence of transactions that have already happened on a loan. Output the schedule amortization payment until it is paid off. This is like really not a hard problem here. Various quirks of the loan program, such as borrowing additional principal after repayment had begun, had to be accommodated. I defined a model for the sequence of events that can happen to the loan independently from our database schema and made each of these operations a data class. I wrote a function, imperative in implementation but stateless, to generate the remaining principal and interest payments for a loan with the given terms and existing payments. To dig up edge cases, I wrote hypothesis tests that basically ran the schedule function and checked that a final balance on the loan after applying every scheduled payment was 0. That worked. I fixed some bugs. Finally, off in a complete different file, I wrote the code that translated this data back into the database entries that stored the schedule for use elsewhere in the web application. It all worked really well, and I could actually understand what this crucial part of our business logic was actually doing. It's been well over a year since I did the work, and I'm still pretty delighted when I think about it. Did I ever tell you the time that I rewrote a large part of Netflix's Falcor request management? Well, there's this part that in Falcor, when you request data, inevitably some of the data you are requesting is actually currently out in another request. Some of the data that you're requesting actually already exists within the cache. Some of it needs to be requested to a specific service. When I looked at this code, I said, ew. This is poorly written. Why would you do it this way or that way? Why is this being done? This is absolutely absurd. Not good. No way. Not going to happen. So what did I do? Well, I rewrote it. First, start out with something simple. Just go to the database. Easy. Then I thought, okay, next easy one is make sure first, what can I get from the cache and kind of do like a complement of the remaining data to go get. So I did that. What's in the cache? What's in the request, get the complement, and then go request that one. Pretty easy, right? And well, then I had to tackle this problem right here. There's requests that are already outbound. How do I make sure that I don't request the same data twice? Well, that means I had to have another Venn diagram in which I took the remaining of this, right, with the missing amount in, and then take the complement again, and now only request this part. Well, after I got done, I almost produced line for line the same code. Easy clap. It produced into me a very, very, very memorable moment in my life. The best way to understand something is to write it yourself. But don't look at code and think you're going to write it better. You're probably not. Generally speaking, this one obviously sounds like he wrote it better, or at least he wrote it different that made it easier. But this could be rear view mirror improvement, right? So something very important about this is maybe when the code was first written, it was much similar. It didn't need all of these different payments, maybe to be able to retake new balances or be able to re-up your loan, to be able to re-borrow against it. Like all the stuff that came in later could have happened. Thus, what it was originally designed for versus what it was used for just becomes kind of sucky. We all have been there. Often you just have to say, burn that shit down to the ground. Let's rewrite it. And so rewriting it actually makes it better. Totally reasonable. So just something to remember. Something to remember. There are times where it does make it better, but often you're just rewriting something and it will end up pretty much the same way. Maybe a couple differences here and there. As far as programming in Haskell goes, my next milestone came when I read Jack Keeley's brilliant article, Text Mode Games as First Haskell Projects. It lit a fire in me and I sat down and tried out. By the way, that's why I'm doing text-based games just to kind of start getting a little bit familiar with game programming and real-time gaming and input and creating clients and aligning things, because text mode gaming is just much easier form of gaming, generally speaking. I didn't get extraordinarily far, but I wrote a tiny game-like creature that could spawn monsters for the player to encounter and attack and or run away from, complete with randomized hit points and attack damage. I still didn't feel like I was ready to be useful with Haskell, but making a tiny effort to at least have fun was refreshing. Dang, that much Haskell and you still don't feel ready? Dang, man. Haskell has to be a really hard language. The real breakthrough came after I got laid off in October 2023 and went freelance. Oh, this must be his thing, Duck Rabbit Solutions, offering a range of software systems and data engineering services. I have particular interest in investigating and documenting legacy code and helping small and inexperienced teams get a handle on stuff that's big, old, and critical. If your organization has something scary and weird that you need help understanding, whether an internal app, a legacy code base, or a subtle business process, send me an email and tell me about it. Duck Rabbit Solutions. To my amazement and gratitude, my first client came calling quickly, thanks to 10 years of posting on niche message boards. I negotiated an hourly rate so I needed to start tracking my time. I threw together a tiny schema for time tracking and Squeal Lite and wrote a hasty shell script to clock in and out with. I handled my reporting needs for submitting my invoices by composing appropriate queries in the SQLite REPL and hitting the up arrow. I knew I wanted to write a real program to handle this stuff, and I started writing it in January in Haskell. The month to write Haskell, the most depressing month of the year. Nice. Unless if you're in Brazil, then it's an amazing month. But for us, it's a very depressing month. I succeeded. I wrote an honest-to-gosh, real useful Haskell program. It parses command line options and talks to the databases. Like a real program. I can clock in and clock out and backfill hours I missed tracking. It converts UTC times to my time zone. It can print hour reports grouped by day or month. It passes functions into functions. It has yo, bro, I heard you like functions, so I put functions in your functions. It has data types for my client accounts and for time entries. And for the various operations that can be run. It doesn't do any fancy M-word stuff. That must be monads. The M word must be monads. That must be what he meant earlier when he said the M word. I didn't understand what it meant when he said fancy M word stuff. I didn't know what that meant. I was like, what the hell is M word? Now I know what it is. Do you want to know the easiest way to understand what a monad is? It's very, very simple. What I want you to do is when you hear monad, I want you to think of one thing. Just simply think of a little burrito, nicely wrapped up. Boom. That's it. And once you can visualize a monad like a burrito, it becomes so simple. It's all in one file. It's not pretty, and I don't think it has great discipline about boundaries yet, but it compiles. And when I want to change something, the compiler helps. My white whale since I was 19, a useful program in Haskell, finally harpooned. Harpoon mentioned. Is that harpoon mentioned? Did we get harpoon mentioned? Let's go. We did it. Harpoon mention. What fascinated me about Haskell is when I was still a teenager. Who knows? I had been coding and with increasing enthusiasm since I was like 10 or 11, but I was no wonderkind. I certainly hadn't attained anything like the skill or, more importantly, taste I had after just a few years in working in the world or in the working world. What I liked about it today is that it's quite natural to program in Haskell by building a declarative model of your domain data, writing pure functions over that data, and interacting with the real world at the program's boundaries. That's my favorite way to work, Haskell or not. You know what the funny part is? Like, real talk, I'm writing my first game, and I'm writing it in Zig. And that's literally what I did. Is the first thing is I built the boundaries, how to do FPS, how to do output. I build up all the frames, do all the output. This is just kind of junk code to try to get me to understand it. And then after doing that, I'm now building my game state. And literally my game state is just going to be taking in something, and every single time a round happens, I make a clone, and that's that. So I can actually play each round as I go. I think it's actually pretty dang cool to go that way. So that way I just have this really, really nice experience of just okay, I have my boundaries. I know how to interact with the system. Now I'm going to create this kind of stateless game state that I just interact and produce new states on top of it. I can think of all of my invariants, right? Like when you call next round, I expect player 1 and player 2 to both have played the same amount of moves, because that's how we're doing it with our tower defense. So I have all my asserts in here that are needed all throughout everything, and they're all right there. So that's really nice to me. is that I can say, hey, here we go. Here's all the different ways in which we can have things that can happen. I expect these different things to happen, right? Like during an update, I expect them to either have the same amount of moves or they have, what's it called? They have a difference of one. So I program in all my invariants, and now I know that by the time I actually have to program the logic, it's just like safe and good. And anytime I mess up, it will just blow up, and I'll be easy to fix it. I'm very happy about that. So, it's funny. Even though I've never programmed Haskell, I've generally picked up the same process for writing code. So it's good. And this, again, is why you should try programming in other languages. You'll eventually come to this type of conclusion, and it makes life really easy, and you're able to start seeing these breakdowns that are very hard to explain and very simple to do once you cross that boundary. Anyways, this is a good article. Very interesting article. I think it also just goes to show that Haskell is a hard and obtuse language, right? The thing is with Go, writing just a little bit of Go within a pretty small amount of time, I understood a pretty good way to write good Go. One program in, I'm like, I already feel pretty well equipped to write more Go. But it sounds like you had to do quite a few bit of Haskelling to become well equipped. Good to go. Anyways, the name. Oh yeah, by the way, thank you. Whoever that brand new viewer that recommended the article, thank you. I appreciated that. The name is the Primeagen.